Okay. So now we are starting quick sort algorithm. So quick sort is based on three-step process of divide and conquer approach. So what is divide and conquer approach? We divide the problem into smaller pieces. Suppose we want to solve an array A, P to R, then we have to follow the following steps. First, divide the problem. We can divide a big problem or the large problem into smaller pieces of a problem. That should be of same type. Then conquer, sort recursively, then combine, merge the solution. So on these three steps, we follow the whole sorting technique. That is quick sort. So in quick sort, what we do step by step. First, we divide the problem. Partition A P2R into two possibly empty subarrays A P2Q and A Q plus 1 to R, such that each element in the first subarray A P2Q is less than equal to each element in the second subarray A Q plus 1 to R. Clear? When we divide a whole array A P2R into two smaller pieces, then the condition is the left subarray element should be lesser than the right subarray elements. Concho, sort the two subarrays by recursive calls to quick sort. Then what we do? Then we individually, or you can say partitioned subarray or the smaller pieces of array, then we solve these recursively. Clear? Finally, we combine. Then no work is needed to combine the subarray because they are already sorted. In quick sort, there is no work in this third step, combine. But when we will discuss merge sort, then there is a big task in the combine. Clear? So that depends on the working of the algorithm. Here, perform the divide step by a procedure partition. Another algorithm, it's a part of quick sort in which we partition the array into two subarrays, which returns the index q that marks the position separating the subarrays, the point by which we have to sort the array, but by which we have to partition the array. So the partition algorithm will give you the point from where you can break your array into two subpieces. Here is example, very simple example. I have already discussed so many examples in sorting. So here we are taking an array A, elements 10, 7, 8, 6, 9. So here the quick sort algorithm is written. Quick sort A, P, comma, R. P is the starting index, R is the last index. If P is less than R, then Q is equal to partition A, comma, P, comma, R. Quick sort A, comma, P, comma, Q, and quick sort A, comma, Q plus 1 to R. It means when we call partition algorithm, it gives you the partitioning element, that is Q, by which we will divide our array into two subarrays. Again, we recursively call the same algorithm quick sort for A, P to Q, and Q plus 1 to R. Initial call is always start from starting index 1 and last index is n. Array name is A. Here you can see A, 10, 7, 8, 6, 9. P is 1, starting index is 1. And R, that is the last index, which is 5. Clear? So now we have to find first Q, which is the partitioning element, from where we have to partition the array. So here P is 1, R is equal to 1, and P is less than 5. So condition is true. Condition is true. P is less than R. Call partition A, comma 1, comma 5. So this is the partition algorithm. You can just understand the concept of partition algorithm. A, comma P, comma R. X is equal to AR. So first we are copying the last element into a variable X, and I is equal to P minus 1. P is what? That is the starting index 1. So I will be P minus 1, that is 0. Now we will start a loop. J is equal to P to R minus 1. Then P to R minus 1 means is starting from first index 1. R minus 1 means up to 4. So for loop will be executed for first, second, third, and fourth. That will be executed 4 times. Do if aj is less than equal to x. J is 1. A1 is 10. 10 is less than equal to x. X is what? AR. R is what? That's the last index. So क्या हो गया? A5. AR. A5. That is x. X is 9. So we have to compare 10 with 9. If this is less than this, then do something. Otherwise, do nothing. देखिए पहले स्टेप में क्या हुआ? Do nothing because 10 is not less than x. Clear? X is 9. But in second step, what happened? 7. 7 is less than x. Clear? Then there will be a change. I is equal to I plus 1. So I is equal to 0. Then it will be increment by 1. Exchange AI with AJ. तो हमने क्या किया? AI with AJ को exchange किया. दोनों को exchange कर दिया. AI with AJ exchange. Now 7 is here and 10 is here. Clear? Now come to the next part. Now J is 3. Now compare AJ, A3 and 8 with X. 8 is again less than X. Then increment I by 1, 2. Now exchange AI with AJ. 8 is here and 10 is here. Clear? Now again increment J by 4. 4. Clear? Compare with 9. Less than 9. Then increment I by 1. Now exchange I and J. 10 and 6. Clear? 6 is here and 10 is here. Now loop is completed because it will execute for the R minus up to the R minus 1. So now you can see our first partitioning element is what? That should be written by this algorithm. Last I. Okay. So that will be stop and return I is equal to 3. Clear? So now our partition will be like this. 2 is equal to 3. 1, 2, 3. First partition. And 4, 5 second partition. Now call quick sort for this sub array, and now again call quick sort for this sub array. Here you can see. Clear? Here you can see this array. This quick sort will again call this sub array A, P to Q, that is 1, 2, 3, and this quick sort again call, and this will call 4, 5. Q plus 1 यानी Q is 3, 4 to 5. समझ में आ रहा है? यहां तक क्लियर है? एनी डाउट? Is there any doubt or everything is clear? Yes or no? There is no voice from your side. कोई भी स्टूडेंट एक रिप्लाई तो करिए अगर समझ में आ रहा है तो. आवाज आ रही है मेरी? हेलो.
यस सर.
यहां तक क्लियर है? कोई डाउट है किसी को?
नहीं सर, क्लियर है.
क्लियर है. ओके. अब समझ में आया? अब मींस the main problem is divided into two sub problems, and these sub problems now again follow the same rule, same partition, same quicksort algorithm. Again they will be partitioned into two sub arrays. Now you can call it as again a separate problem, that is sub array A 1, 2, 3. So here again x is equal to 6 AR and I is equal to J minus 1, that is P minus 1. Clear? J is equal to P to R minus 1. If AJ 7 is less than X, no. And increment, do nothing. Increment J. J is again, now J is 2. AJ, that is 8 is less than 6, no. Do nothing. Terminate. So now here you can see the I will be what? Partition क्या होगा? लास्ट में I की वैल्यू कितनी हुई? 0. I बढ़ा ही नहीं. There was no increment in I. So again that will be, because this is, you can say this is the sorted, already sorted. That's why there is no need of the partition. One part, this part is clear. 6, 8, 7. But 8 should be on the right side. Clear? So because, just a minute, check it again. देखिए यहाँ पर क्या changes हुए. When we compare 7 with 6, because 7 is greater than 6, no change. Come to the 8. 8 is again greater than 6, no change. Clear? Now J is 2, R is 3, I is equal to 0. But when you don't write anything on the screen, when you terminate this for loop in last, then what happened? J is equal to 2, R is equal to AI plus 1. Clear? AI plus 1. I is 0. A1. A1. Exchange with AR. That last step should be executed. When you execute this step, then 6 will come at position 1 and 7 will come at position 3. Clear? And return I. Stop here. I रिटर्न करोगे तो क्या होगा? एक पार्टीशन हो जाएगा 1 का, एक हो जाएगा 2 और 3 का. क्लियर? यहां पर देखा आपने? जीरो हुआ था. व्हाट वाज द आई की वैल्यू कितनी थी? 0. तो 0, तो इसका मतलब कोई पार्टीशन ही नहीं हुआ यहाँ पर. ठीक है, क्विक सॉर्ट में अब आगे बढ़ते हैं. अब देखिए यहाँ पर A13, अगेन विल कॉल इट 13. then what will happen? J is equal to 1. Compare 6 with 7, which is less than this. क्या होगा? I is equal to I plus 1. I इंक्रीमेंट होगा और I और J दोनों 1 हो गए. Now exchange AI with AJ, because both the values of I and J are same, 1, 1. There will be no change. Now increment J by 2. 8. 8 is less than 7. No. Then what will happen? Do nothing. Clear? Now I is 1. So I plus 1. Exchange I plus 1. 2 with this R. So 3 will come, 7 will come at position 2nd and 8 will come at position 3. Clear? And return I 1. 7 यहाँ आ गया, 8 यहाँ आ गया और रिटर्न क्या कर दिया? I. तो पार्टीशन क्या हुआ? 6 इधर टूटा और 7 और 8 इधर टूटा. Is it clear? Any doubt? समझ में आ रहा है? Because we are following divide and conquer algorithm, which is totally based on the recursion. Clear? Parallelly, you can see this array will again called by the quicksort A 4, 5. What will happen? Because this is lesser than this, there will be no change in the I, and no partition will be there because this is already sorted. Now you can see this is already sorted. This is already sorted. So what will happen? देखते हैं. Let's see क्या होता है. 7 is less than 8 as per the algorithm. No change is there. What will happen? Finally exchanged, nothing else, and this is the final result. You can see 7, 8, 6. So now you will see in last the right part. The right part, what will happen is again similarly break into two sub portions 9 and 10. So here you can see what we have done to sort this array in whole algorithm. What we have done, हमने क्या किया? Array लिया, array को टू पार्ट्स में ब्रेक किया. Q की वैल्यू निकाली सबसे पहले. Q कहां से निकाला? पार्टीशन से निकाला. पार्टीशन एल्गोरिथम ने दो पोर्शन किए. फिर अगेन हमने क्विकसॉर्ट को कॉल किया रिकर्सिवली लेफ्ट पार्ट के लिए, फिर राइट पार्ट के लिए. देन व्हाट विल हैपन? दिस इज for first time there was no partition, but in second time there was a partition 6 and 7, 8. 7, 8 is again partition into 7 and 8. 9 and 10 again partition into 9 and 10. So what happened? The data is already stored in the array. So these values are overwritten, and finally the result is this. So we have divide, we have conquer, but there's no work. There was no work for the combine. This is the final result. So what happened? This is the when we call a quick sort, first iteration, second iteration, third iteration, and this is the sorted. So now we have to discuss the performance analysis of quicksort. The running time of quicksort depends on the partitioning of the subarray. If the subarrays are balanced, then quicksort can run as fast as merge sort. If they are unbalanced, then quicksort can run as slowly as insertion sort. If we see the worst case occur when the subarrays are completely unbalanced, have 0 elements in one array and n-1 element in the other array. Get the recurrence and Tn is equal to 2n-1 plus T0 plus theta of n. So when we solve it by iteration method, then we see the Tn, the time complexity of this in worst case of quicksort will be theta of n square. Same running time as insertion sort. As we know, the insertion sort is also takes theta of n square in worst case. So in fact, the worst case running time occurs when quicksort takes a sorted array as input, but insertion sort runs in O(n) in time in this case. अगर हम बेस्ट केस की बात करते हैं तो इंसर्शन सॉर्ट हमारा कितना लेता है, O(n) टाइम लेता है. क्लियर. इनफैक्ट वर्स्ट केस रनिंग टाइम अकर्स व्हेन द क्विकसॉर्ट टेक्स अ सॉर्टेड एरे एज. अगर क्विकसॉर्ट में हम सॉर्टेड एरे भी डालेंगे, ये क्वेश्चन जनरली पूछ लिया जाता है, विच वन इज बेटर एल्गोरिथम. पर स्टूडेंट्स क्या कहते हैं, क्विकसॉर्ट का नाम ले देते हैं. क्विकसॉर्ट इज बिकॉज नेम सजेस्ट क्विकसॉर्ट करता है. No, in quicksort, if you are putting the sorted array, then it takes again theta of n square because comparison होगा ही होगा, partition होगा ही होगा. Clear? But in insertion sort, if it is already sorted, then while loop will not execute it, and its best case time complexity will be O of n. The best case occurs when the subarrays are completely balanced every time. Balance क्या होता है? Occurs when the subarrays are completely balanced. Completely balanced means we are dividing the array into two equal half elements. Equally half elements. Suppose the array size is 8, then the subarrays will be of size 4, 4, 2, 2, 1, 1, like this. That will create a binary tree. At that time, the recurrence will be Tn is equal to 2Tn by 2 plus theta of n, and the running time, the time complexity will be theta of n log n. So in best case, it is very much faster algorithm. So this is the performance analysis of quicksort. Here you can see how we have done it. Tn is equal to Tn-1 plus T0 theta of n. You can solve it by iteration method, I think, which was discussed in unit number 1. If we are solving Tn is equal to 2Tn by 2 plus theta of n, when it is divided into two equally half subarrays, then using master theorem, A is equal to 2, B is equal to 2, compare n to the power log A base B with theta of n, n to the power log A base B. A and B are both are 2, 2. So log of 2 base 2 will be 1, that is n is equal to n. So what will be the time complexity? In equal cases, at theta to the power n log theta to the power theta n to the power log A base B log n, that is the formula. So put the value of theta of n, theta to the power log A base B, that is n, and log n is the time complexity in best case. So this was the finally time complexity we have calculated. In best case, theta of n log n, and in worst case it is theta of n square. Yes, any query? I think session is completed.